Hello friends, let's start new topic, convexity. In this video we will be covering concept of convexity, what it is and how to calculate convexity and how to use convexity for calculation of new price for a bond after change of yield in the market. So all these three topics we are going to discuss here. For calculation of convexity, we will be making our calculation as on a settlement date, which is equals to coupon date. हमारे study material में what institute has covered calculation of convexity on coupon date for annual as well as semi-annual bond. But convexity can be calculated on a settlement date other than the coupon date also. उसको नहीं कवर करेंगे, रेस्ट्रिक्ट रखेंगे जहां तक हमारा स्टडी मैट हमारे लिए जरूरत रखता है. हाँ, कोई बहुत बड़ा डिफिकल्ट काम नहीं होगा, बट मैनुअल कैलकुलेशन थोड़ी सी डिफिकल्ट हो जाती है. आप MS एक्सेल पे जरूर बहुत इजीली कैलकुलेट कर सकते हैं, बट हम यहां पर कॉन्सेप्ट की बात करते हैं तो कॉन्सेप्ट के लिए हमें इजी इलस्ट्रेशन से भी काम हो जाएगा. बिफोर गोइंग फॉर कॉन्वेक्सिटी, एक्सपेक्टेशन रहेगी Macaulay duration, modified duration and use of modified duration. Modified duration का calculation और उसका use, approximate modified duration का formula, ये सभी को आता है. उसी के बाद ये टॉपिक शुरू करना है, नहीं तो डिफिकल्टी हो जाएगी समझने में. Let's move to topic, what is convexity? Convexity क्या है? इशू कहां से आया? when we have already arrived at a formula of modified duration which shows change in PV full value, full price means bond full price with respect to change in yield. इशू ये था कि जो हमारा ये modified duration का जो कैलकुलेशन है, ये फर्स्ट डेरिवेटिव है बॉन्ड प्राइस यील्ड इक्वेशन का. और जहां मैंने फर्स्ट डेरिवेटिव की बात की मींस dy अपॉन dx, जो डिफरेंशिएशन हमने यूज किया, फर्स्ट डेरिवेटिव हमें स्लोप ऑफ लाइन कैलकुलेट करके दे रहा है. बेसिकली हमने देखा था प्राइस और यील्ड का रिलेशनशिप एक कर्व नेचर का है, इट्स नॉट ए स्ट्रेट लाइन. तो जहां पे आपने फर्स्ट डेरिवेटिव लिया और मॉडिफाइड ड्यूरेशन कैलकुलेट किया, एक्चुअली हमने क्या कैलकुलेट किया? वी हैव कैलकुलेटेड स्लोप ऑफ द लाइन विच इज टेंजेंट एट द पॉइंट जहां पर आप कैलकुलेशन कर रहे हैं. सो अगर ग्राफिकली समझें तो एक छोटा सा एग्जांपल लेते हैं. लेट्स अज्यूम वी हैव अ कैश फ्लो ऑफ 100 रुपीज. एक जेड बॉन्ड की ही बात करते हैं. एक जेड बॉन्ड की अगर बात करता हूं तो कैश फ्लो 1 साल का जेड बॉन्ड है and the maturity value is 8%. So if my discounting rate is 8%, 10% and 12%, what will be the PV? The PV will be $100 over 1.08 means 92.5926. Next, we have increased the yield by 2%, desired yield by 2%. It will give us 90.9090. And if we increase it to 12%, again positive 2, same percentage change, incremental 2% extra, what we are going to get? 1 upon 1.12, that is 89.2857. Very simple example of a single cash flow coming at T1 at the end of first year, and we are discounting it by 3 different rate, 8, 10 and 12. So there is an equal gap between the rate, that the rate which is the independent variable and the PV which is dependent variable. So independent variable में हमने equal changes किए हैं, और जब हमने equal changes किए, let's say R0 is your 10%, R plus is your 12% and R minus is your 8%. What we actually got is the prices are 92.5926. तो एक काम करते हैं, इन प्राइजेस का भी डिफरेंस ले लेते हैं. और जैसे ही हमने इन प्राइजेस का डिफरेंस लेना शुरू किया, what we got? 9090 gives you a decrease in price of 1.6233 और फर्स्ट लेवल से सेकेंड लेवल भी डिक्रीज करके देखते हैं 92.5926 माइनस 90.9090 वी गॉट नेगेटिव 1.6836। तो ये क्या शो कर रहा है? व्हाट इट शोज? इट शोज दैट फॉर इक्वल चेंज इन योर डिजायर्ड यील्ड इंडिपेंडेंट वेरिएबल, आपका जो प्राइस था, बॉन्ड प्राइस जो था, प्रेजेंट वैल्यू ऑफ ऑल कैश फ्लोज, उसमें जो चेंज आया दैट इज नॉट इक्वल, वो इक्वल चेंज नहीं ला रहा है। तो जैसे ही वो इक्वल चेंज नहीं ला रहा है तो अब उनको प्लॉट करके देखते हैं। तो हमें समझ में आया कि अगर हमारा ये वैल्यू, ये लेवल 90.90 था, तो R-1 पे जब हम जाते हैं तो इट इज इक्वल्स टू 92.5926, वेयर एज जब R प्लस पे गए तो हमारा ये वैल्यू इज 89.2857। ग्राफिकली अगर समझें, जो इंक्रीज हुआ था दैट इज एट 1.6836 और जो डिक्रीज हुआ है वो 1.6233। मींस इंक्रीज इज हैपनिंग एट अ इंक्रीजिंग रेट। ऑफ कोर्स थोड़ा सा ग्राफ हमने विदाउट यूजिंग ग्राफ पेपर यूज किया तो थोड़ा सा अप एंड डाउन है, बट ठीक है, समझने के लिए ठीक है। ये कि जब इंक्रीज हो रहा है तो इट इज हैपनिंग एट अ इंक्रीजिंग रेट, एंड जब वो डिक्रीज हो रहा है तो इट इज हैपनिंग एट अ डिक्रीजिंग रेट। और ये जो नेचर है ये एक स्ट्रेट लाइन का नहीं है। स्ट्रेट लाइन में इंक्रीज एंड डिक्रीज शुड बी देयर विद अ कांस्टेंट स्लोप। स्ट्रेट लाइन का इक्वेशन होता है y इक्वल्स टू 2 प्लस 3x और आई कीप इंटरसेप्ट एज 0। इन दैट केस अगर आप x1 रखते हो तो y is 3, अगर आप x2 रखते हो y is 6 एंड x3 रखते हो तो y is 9। देयर इज अ इक्वल चेंज एट एवरी पॉइंट। तो ये जो नेचर हुआ कि इंक्रीजिंग एट अ इंक्रीजिंग रेट, डिक्रीजिंग एट अ डिक्रीजिंग रेट, ये स्ट्रेट लाइन का नेचर नहीं है, ये एक कर्व क्रिएट कर रहा है और ये कर्व है फेसिंग टुवर्ड्स ओरिजिन, तो इसको बोलते हैं हम कॉन्वेक्स कर्व। हमें भी समझ में आया, हमने भी बॉन्ड प्राइस का जब वैल्यूएशन किया तो बॉन्ड प्राइस के जो बॉन्ड का जो वैल्यूएशन किया उसमें जो प्राइस निकाली उसमें हमने व्हाट वी हैव डन, वी हैव डिस्काउंटेड ऑल कैश फ्लोज व्हाटएवर वी आर गोइंग टू रिसीव बाय होल्डिंग दैट बॉन्ड। So when we are doing discounting, तो ये एक स्ट्रेट लाइन यानी कि कांस्टेंट चेंज नहीं क्रिएट कर रहा है, इट इज क्रिएटिंग ए कॉन्वेक्स कर्व। सो फाइनली समझ में आया कि बॉन्ड प्राइस यील्ड रिलेशनशिप इज अ कॉन्वेक्स रिलेशनशिप, एंड ये हमारे लिए कॉन्वेक्स कर्व क्रिएट कर रहा है विच इज दिस ब्लू कर्व, बॉन्ड प्राइस यील्ड रिलेशनशिप। वेयर जब हमने मॉडिफाइड ड्यूरेशन फर्स्ट डेरिवेटिव कैलकुलेट किया, उसने क्या किया कि जिस पॉइंट पे हमने कैलकुलेशन किया था, जिस सेटलमेंट डेट, जिस यील्ड और जिस प्राइस को लेके हमने वैल्यूएशन कैलकुलेशन किया, इट एक्चुअली गेव अस द स्लोप ऑफ दैट पॉइंट कंसिडरिंग इट एज अ स्ट्रेट लाइन। इट मींस उसने मॉडिफाइड ड्यूरेशन ने एक टेंजेंट को यूज किया जो उस पॉइंट पे, उस कर्व के उस पॉइंट पे टेंजेंट है, दैट इज दैट रेड लाइन, और उसका स्लोप क्रिएट करके दिया 3 टाइम्स 4 टाइम्स। इट सेज 3 टाइम्स मींस अगर आप, और नेगेटिव था मॉडिफाइड ड्यूरेशन, सो अगर आपका यील्ड गिरेगा तो प्राइस बढ़ेगा एंड वाइस वर्सा। तो नेगेटिव रिलेशन वाज ओके, बट द इशू इज कि स्लोप लाइन का था, कर्व का नहीं था, एंड प्राइस कर्व क्रिएट कर रहा है, प्राइस यील्ड कर्व क्रिएट कर रहा है। तो ये जो डिफरेंस आ रहा है, ये जो डिफरेंस आ रहा है आपका, ये जो डिफरेंस आ रहा है दोनों प्राइस और कर्व के बीच में, दिस डिफरेंस इज कॉल्ड एज कॉन्वेक्सिटी। तो अब हमें इस कॉन्वेक्सिटी को क्या करना पड़ेगा, हमें इस कॉन्वेक्सिटी को भी कैलकुलेट करना पड़ेगा, ताकि जो इसका मतलब जो मॉडिफाइड ड्यूरेशन से जो हमने प्राइस कैलकुलेट किया यूजिंग दैट फॉर्मूला, न्यू प्राइस इफ देयर इज अ चेंज इन यील्ड, दैट इज जस्ट एन एस्टिमेट। वो एक्चुअल प्राइस नहीं दे रहा है हमें, या इवन नियरर, जस्ट इट्स जस्ट एन एस्टिमेट नियर टू द एक्चुअल प्राइस। हमें वो जो डिफरेंस है ब्लू कर्व और रेड लाइन के बीच का, वो एक एक्स्ट्रा अमाउंट है जो हमें उस एस्टिमेट में ऐड करेंगे तो ही हमें बॉन्ड के एक्चुअल प्राइस के ऑलमोस्ट नियरर वैल्यू मिलेगी। और एक चीज समझ में आई, ये दोनों ही केस में ऐड हो रहा है, बिकॉज कर्व चाहे r माइनस हुआ चाहे r प्लस हुआ, दोनों ही केस में कर्व आपकी रेड टेंजेंट लाइन से राइट हैंड साइड है, यानी कि ऊपर है. So this convexity effect should be added irrespective of change in yield, that is yield नीचे गया या yield ऊपर आया. अब क्वेश्चन ये है कि ये जो डिफरेंस है कर्व और लाइन के बीच का, ये कॉन्वेक्सिटी जो है, इसको कैलकुलेट कैसे करें. तो अगेन इसका सॉल्यूशन हमारे पास डिफरेंशिएशन में ही है. डिफरेंशिएशन में अगर हम सेकेंड ऑर्डर ऑफ डेरिवेटिव क्रिएट कर दें तो व्हाट इट विल गिव कि y2 upon yx square. How much the first derivative itself is changing with the change in the yield? How much is the first derivative itself is changing with the change in yield? तो ये जो काम है, ये जो है, ये बेसिकली क्या करेगा, ये बेसिकली हमारे लिए एक और लाइन क्रिएट करेगा. और ये एक लाइन कहां पे होगी, वो जो सेकंड पॉइंट जहां पे आपने ये कॉन्वेक्सिटी का इफेक्ट कैलकुलेट किया, ये उस लाइन का स्लोप और आपके रेड लाइन के स्लोप के बीच का जो कैलकुलेशन है वो हमें कैलकुलेट करके दे देगा. तो हमें क्या करना है, हमें प्राइस यील्ड रिलेशनशिप का ही सेकंड डेरिवेटिव तक पहुंचना होगा. ऑफ कोर्स डेरिवेशन कोर्स में नहीं है, ऑफ कोर्स डेरिवेशन कोर्स में नहीं है. तो हम डिराइव कर सकते हैं, बहुत इजी है, कोई और मुश्किल नहीं, सिर्फ एक स्टेप और आगे जाना है, सिर्फ एक स्टेप और आगे जाना है. क्या है वो स्टेप, देख लेते हैं थोड़ा सा फटाफट. वैसे पार्ट ऑफ नॉट सिलेबस हमने किया, पीवी फुल इज इक्वल्स टू पीएमटी अपॉन 1 प्लस आर पावर 1, 1 प्लस आर पावर 2, 1 प्लस आर एंड सो ऑन टिल पीएमटी प्लस एफवी 1 प्लस आर पावर nth. If we take dpv upon dr, the first derivative, it will give us minus 1 upon 1 plus r pmt. ये हम ऑलरेडी मॉडिफाइड ड्यूरेशन के कैलकुलेशन में सीख चुके हैं. 1 plus r power 1, 1 multiplied by 2 multiplied by pmt upon 1 plus r power square and so on till n multiplied by pmt plus fv upon 1 plus r power nth. ये हमने मॉडिफाइड ड्यूरेशन में भी देखा था. व्हाट आई एम डूइंग इज, मैं इस 1 प्लस आर को वापस अंदर लेके जा रहा हूं ब्रैकेट से, तो दिस विल बिकम द डिनोमिनेटर विल इंक्रीज देयर पावर्स. लेट्स गो फॉर द सेकंड डेरिवेटिव, d2pv upon dr square. This will give, this minus will become now plus, but 1 multiplied by 2, not 1 multiplied by 2, sorry, minus will come in front, so it will become plus 1 multiplied by 2 multiplied by pmt upon 1 plus r power cube, 2 multiplied by 3 multiplied by pmt upon 1 plus r power 4 and so on, n multiplied by n plus 1 pmt upon pmt plus fv whole upon. अगर आपको डिफरेंशिएशन नहीं आ रहा है, टेंशन नहीं है, मैंने डिफरेंशिएशन किया है, ये कोर्स का पार्ट नहीं है, हमें सिर्फ लास्ट फॉर्मूला यूज करना है. तो अगर हमें लास्ट फॉर्मूला यूज करना है तो हमें थोड़ा सा बस समझना होगा कि वो फॉर्मूले के वेरिएबल्स कहां से आए, वेरिएबल्स कहां से आए. डेरिवेशन की हमें जरूरत नहीं है, जिन्हें आता है उनके लिए ठीक है, अदरवाइज जरूरत नहीं है. 1 प्लस आर की पावर n प्लस 2. So this becomes your second derivative. Now we will take common d2pv upon dr square multiplied by 1 upon pv. This is equals to 1 upon 1 plus r power square. So r power square is common with a positive sign. This is important. 1 multiplied by 2 multiplied by pmt upon 1 plus r. 2 multiplied by 3 multiplied by pmt upon 1 plus r square. And last, n multiplied by n plus 1 pmt plus fv whole upon 1 plus r n whole upon pv. We have multiplied, we have divided both side by PV full. If we see this equation, this is d2 PV upon dr square multiplied by 1 upon PV is equals to 1 upon 1 plus r square. And what I am saying is r is 1 plus r square, and r represent your yield, not per annum, per period. So if it is a semi-annual bond, we have to divide yield by 2 periodicity. And this is giving us 1 multiplied by 2 multiplied by PMT. So if I say that 1 plus 2, or I'll take some 1 multiplied by PMT upon PV 1 plus R whole multiplied by 2 plus 2 multiplied by PMT upon PV 1 plus R square whole multiplied by 3 plus n multiplied by PMT upon PV 1 plus R to the power nth multiplied by n plus 1. Why I have shifted 2, 3 and n plus 1 separate from the these numbers? If you see this number, the first number, we have already done this calculation in the which part? The calculation of modified duration. The column in table, the column what we are using is the weight into time is the same values. Weight is your PMT, discounted present value, discounted cash flow, that is the present value of the cash flow, divided by PV, that is the weight. So we have what we have done. PMT got discounted by 1 plus R power 1. PMT, second PMT got discounted by 1 plus R power 2. It becomes weight. Then we have, it becomes the present value. Then we have divided all values with PV. So it becomes weight. And then weight got multiplied by their respective timings. So the column what we have already calculated in the calculation of modified duration and Macaulay duration, WT, that is weight into time, is available with us. We have to only do two things. Each number into weight into time column should be multiplied by t plus 1 also. Second, third and n plus 1. And the summation should be divided by 1 plus r to the power square. That is the formula for convexity. That is the formula for convexity. So convexity is equals to, what is the convexity? It is weight multiplied by time plus 1 whole sigma whole upon your 1 plus r to the power square. Now again, this convexity number is also annualized. Convexity number is also annualized. So if you are calculating it for a semi-annual bond, I'm repeating again, in case of modified duration, we were dividing it by periodicity. The summation was getting divided by periodicity. Now in this case, the summation will be divided by annualized convexity will be equals to summation divided by your periodicity square. So we are not going into the detail why we are dividing it by periodicity square. It's just that we have to remember this thing, not in our course, from where this formula got derived. So what is the formula we are going to use? Let's see. What is, first of all, I hope so everyone understood what is convexity. The convexity is the change in the slope of this tangent line with respect to change in the yield. And why we are using this convexity additionally? Because modified duration is giving us only estimate of the new price. It is not giving the price exact price. So to arrive at exact price, we have to additionally add in both cases, whether yield is going to go down or up, we have to add that difference of that curve to that tangent line, and this difference is called as convexity. So what text is saying? Modified duration. A key risk matrix is a linear approximation, the tangent line of a sensitivity of, that is, change in bond price with respect to change in yield. Of course, it is only here we are only talking about one part of the interest rate risk, that is price risk. We are not handling here in reinvestment risk. If you want to set off your price risk with reinvestment risk, you can use Macaulay duration. You can use Macaulay duration as the tenure up to which you should be holding your bond, subject to the condition. There are only one-time change in the yield and it is before the payment of the first coupon. Well, let's move further. So that we have already covered in Macaulay duration. It is the first order linear effect of bond price change given a yield change. In actual, bond price is a curved relationship, so rather than a straight line. So convexity is this is the keyword, complementary risk measure. Complementary risk measure. So it is the key risk matrix, but this convexity is that additional, that change in that slope of itself is what we are using at as what we are here using this term as convexity. So convexity is the complementary risk measure to improve bond price change estimate. It is the second order. Modified duration is the slope of the line. Convexity is the change in the slope itself with respect to change in the yield. Non-linear effect of the yield on the price change. Now, how to calculate convexity? Convexity is T multiplied by your weight, that we have already there in our table format in the calculation of Macaulay duration. That each number should be multiplied by T plus 1, whether it is a coupon payment date or a non-coupon payment date. Just multiply your T with additional 1 and multiply all values with their respective weight into time numbers. And then sum it up for all the cash flows and divide it by 1 plus R, where R is your not yield per annum. It is yield per annum divided by periodicity. So if it is annual, it is annual yield. But if it is a semi-annual bond, you have to divide that yield by 2 and then you have to use 12% will be converted to 6% and we will be using 1.06 power square. Now again, both modified duration and convexity are annualized statistics. So in case of modified duration, what we were doing, in case of modified duration, we were dividing it by, where is annualized? This is modified duration, annualized Macaulay duration. Okay, I use annualized Macaulay duration. Somewhere I must have written this formula. So what is annualized? Okay. Macaulay duration, when it is divided by 2, it will become annualized Macaulay duration, and then it is divided by 1 plus R. Where is the annualized? This is the formula, correct. Annualized modified duration. So what is annualized modified duration? It is the annualized Macaulay duration upon 1 plus R. And what is annualized Macaulay duration? It is actually the Macaulay duration upon 1 plus R into 1 by 2. Macaulay duration got divided by 2 in case of semi-annual bond. So same thing, if you have modified duration from this formula, you can calculate annualized modified duration just by dividing this by additional 2. So this will give you annualized modified duration. Same thing we are going to do here. But the difference is we will be dividing the convexity, this summation of that column by periodicity square. Now, what is the logic? Logic is in differentiation. We are not going for that. So it is convexity divided by periodicity square in case of semi-annual bond. In case of annual bond, there is no issue because periodicity of annual bond is 1. 1 power 2 is also 1. So convexity will remain as the annual convexity. Now, as we have approximation formula, if you do not want to go for tabular format, we have shortcut formulas for even Macaulay duration, modified duration. Same is with the convexity also. For Macaulay duration, if you do not want to make a table, you can go for the which formula? Closed form equation from calculus, integration. That closed form equation can give you the exact value of Macaulay duration. In case of modified duration also, we were using this approximation formula of annualized modified duration, PV minus PV plus upon PV0 multiplied by 2 multiplied by yield per annum. Same for annualized convexity, we have a shortcut formula, PV minus plus PV plus minus 2 multiplied by PV0 upon PV0 into yield per annum, change in yield per annum square. Now from where this formula is arrived, we are not deriving this. This is not part of our course. So we are going to use this formula. Let's summarize all these 6 formulas what we already 4 we have already used. What are these 4 formulas? Number 1, Macaulay duration. One way is to calculate this present value, then weight, and then weight multiplied by time. And this total is your Macaulay duration in case of annual bond, annual coupon paying bond, and if it is a semi-annual coupon paying bond, you have to divide it by 2 to arrive at annualized Macaulay duration. Second, when you are second calculation of modified duration, in case of using this table, what we are going to do, we are going to divide Macaulay duration with 1 plus R. If it is a annual yield, it is 1 plus 1.1.12, and if it is a semi-annual yield, it will become 1.06 in case yield is equals to 12%. We have an approximation formula also for Macaulay duration. We can use closed form equation. This will give exact same value, 2.7286, 2.7286. For modified duration, we have an approximation formula, PV minus. We will change the yield, desired yield, by a constant decrease and a constant increase, and we will calculate new prices of the bond, full prices of the bond, and these full prices will be used for calculation of approximate annualized duration using this formula. Third thing, the convexity. Just add one more column to W into T with T into 1, T plus 1 also. So multiply this last column, second last column with T plus 1 additional. So first 0.0938 having a T equals to 1. So 1 plus 1 is 2. We will multiply it with 2 and we will see the calculation also, and so on. And the summation will be divided by 1 plus R square. So if it is an annual yield, it is 1.12 power square. If it is a semi-annual bond, it will be divided by 1.06 power square. And this is your convexity. This is convexity. In case of annual bond, nothing to be done. But in case of semi-annual bond, you have to divide it by not 2, divided by 4, periodicity square. Again, there is a shortcut formula. Same PV minus and PV plus for a constant change in yield by decreasing and increasing the yield. Calculate new prices and use this formula. PV minus plus PV plus minus twice of PV0 upon PV0 into change in yield per annum square. So mind it, everywhere we are using change in yield per annum except one place, Relationship between Macaulay duration and modified duration. Relationship between Macaulay duration and modified duration, there we have 1 plus small r. 1 plus small r. So there we have to take care in case of semi-annual bond. Otherwise, no issues in using the change in yield. Only in case of semi-annual bond, for converting Macaulay into modified duration, we have to convert our yield. Otherwise, everywhere we are using annualized yield change for calculation of new prices or convexity, etc. So let's move to the topic back. Then we are going for 2-3 illustrations. So first we have understood what is convexity, how it is calculated, and what is the approximation convexity formula. And this is going to give annualized number only. Next, how to use this to calculate the percentage change in PV. Not direct PV, it will give, of course, percentage change in PV. So in case of modified duration, we were using percentage change in PV is equals to negative modified duration multiplied by change in yield per annum. Change in yield per annum. But now from this concept, we understood that there is something additional we have to add every time whenever we are going to use modified duration, because your red line is below your blue curve. So you have to add whether yield got decreased or yield got increased in both cases. So convexity will come with positive. Again, the formula derivation is not part of our study mat. So we are not covering the derivation. We are going to use this formula. Till convexity derivation, it was easy. Derivation, differentiation, normally people know. But now this next part, that is use of this convexity formula, we are directly using the formula. It is half of annualized convexity into change in yield square. Change in yield square. So it is always going to be added half of annualized convexity multiplied by change in yield per annum square. This is the formula for calculating new percentage change in PV, and with this percentage change in PV we are going to calculate new PV. It should be now more nearer. Of course, modified duration is giving an estimate of new PV, but it is a bit different. By adding convexity, now this estimate should go more closer to your actual PV. So let's move to the next part. Annualized modified duration is with negative sign, so it will move bond price in the opposite direction. That is okay. But convexity is having positive sign. It will be always added. Thus, this term is always positive, and in case of option-free bonds. So what will happen for a bond with an option, call option, put option? That we are going to cover in later part, that is curve-based duration and curve-based convexity. This is yield-based convexity. So this concept is having certain assumption. First of all, your bond is a fixed rate, coupon paying bond, annual, semi-annual, that is not a problem, but it is a fixed rate, not a floating rate. And second, it is an option-free bond. And third, one more assumption we have taken, that the change in yield is a parallel shift in the curve. All maturities, the yield for all maturities shifted with an equal change. That may not true in all cases, because demand and supply of money is going to affect all tenure equally. That may not be true in all cases. In fact, it is not true at all. So the yield curve generally may move on a parallelly, but generally it will move on a non-parallel fashion. So we will analyze those things also. So this yield-based duration convexity is having limitation. Number one, we are not considering options. Number two, we are doing it for fixed rate bonds. And number three, we are assuming that it is having a parallel shift in the yield curve. Things will improvise with the curve-based duration and convexity. We will cover that later. Thus, this term is always positive for an option-free bond and irrespective of movement of the yield. Next part, we will cover relationships and the overall bond portfolio duration and convexity. Let's do the calculation part. Some illustration I have created. Of course, we are covering it only for a settlement date equals to coupon payment date. This can be done for settlement date on a non-coupon payment date. The only thing is calculation will go into more decimal formats rather than the whole numbers. So let's go for illustration 1, and I have created 3 cases. One is annual bond, second is semi-annual bond, and third is your zero coupon bond. Then I have gone for second illustration where I have covered everything. Macaulay duration table format, closed form equation will give exact same answer. Modified duration table format and the approximate modified duration will give somewhat nearer values to actual PV, new PV. Then I have given convexity, covered convexity in tabular format and approximate convexity. And then how to use this modified duration and modified duration along with convexity. So all these 1, 2, 3, 4, 6 plus 3, 9 calculation I am going to cover now here. So hopefully this will summarize whatever we have done in this risk part of the fixed income topic. And then there is a homework. where you can practice for these this question. And in next part, I will share solution of this illustration. And you can compare it. And this is for semi-annual periodicity. A bit complex, a bit more complicated. So let's go for two illustration. First illustration. Illustration, it is annual bond periodicity settlement 1125, and the maturity is, and the maturity date is 1130. The same bond what we have used in the modified duration calculation, same calculation. So on coupon payment date, flat price is equals to full price. Yield is 12% and coupon rate is your 10%, and yield is your 12%. Face value is your, par value is your 100. So cash flow time 1, 2, 3, 4, 5 year. Every anniversary you are going to get coupon, and at the 5th anniversary you are going to get coupon along with redemption 110. We have discounted it with 12%. Whole numbers are there. Time to receipt is a whole number because we are working it on coupon date only. If it is not a coupon date, it will be in decimal format. That's okay. We will calculate weight. Weightage is equals to PV upon sigma PV. Then we have multiplied weight with time to get the Macaulay duration. This is directly annualized Macaulay duration because the bond is having a periodicity of annual coupon payment. Next, add one more column with this last column W into T. Multiply each number with T plus 1. Multiply each number with the T plus 1. So this 0.0962 will be multiplied by 2, will give you 0.1924. Next, then 0.1718 will be multiplied by 3. The time is 2, so T plus 1 is 2 plus 1, 3. And this will be also added as 0.5154. And summation. This is not convexity. This is not convexity. So convexity of bond is, this is only the summation part. We have to divide it. We have to divide it by what? 1 plus R square. This term, the summation is arrived using additional column, but we have to still divide it by 1 plus R square. So 1 plus R, it's yield per periodicity. So here it is an annual bond, so it will be divided by 1.12. So what we have done, this is your Macaulay duration from table. Modified duration is Macaulay duration divided by 1 plus R, 1.12, and we got the modified duration 3.69. And the last column summation 23.178 will be divided by 1 plus R power square, that is 1.12 square, and we will get the convexity. So these are the three values from the table format. Let's calculate it from approximate formula also. So this is a 12% yield pricing table. Let's change the yield by 50 basis point, that increase and decrease both sides. So 12.5% and 11.5%. So at 12.5%, use this bond formula 10 PV 100. Since we are working on coupon date, we can directly use the third column keys. Otherwise, we will use the bond function to calculate the full price and accrued interest, flat price and full price. 12.5 yield, 5 is your tenure, and we got the price 91.096. Let's change this to 11.5 and we will get the price 94.5252. Both prices are there. Put the prices in the formula of approx convexity. We directly got 18.5364, somewhat nearer to this. Of course, this is approximate. Exact value you are getting from table, but you can calculate it with the approx formula and use this in the formula also of change in percentage change in PV. Second, if it is a semi-annual bond, and I'm going to give a practice question also for semi-annual bond. Now in this case, for 5 years, now it will become 10 periods, 10 semi-annual. So it will go till 10. Coupon will reduce to 5 from 10 divided by 2, that is 5. And last we are going to get 105. Discounted by 6%, not 12%. Yield will also become half, 12 divided by 2. Calculate weight as PV divided by sigma PV, and sigma PV denote your PV full price, bond full price, multiply it with T, and in case of convexity, multiply this column with additional one more column will be there, additional T plus 1. So same 0.0509 will be multiplied by 2. It will give 1.1018. Sum up everything. These are not your annualized numbers. These are semi-annualized numbers. If you want to calculate using this table, annual Macaulay duration is 8 point, the summation of W into T, 8.022 divided by 2. Modified duration, 4.0113 should be divided by 1 plus small r, and small r denote your yield per period, so it will be divided by 1.06 to get the annualized modified duration. For annualized convexity, it will be divided by 1 plus small r, that is yield per period square, that we have done, and it will be divided by periodicity square also. In case of annual, 1 square is always 1, so it is, but in case of a semi-annual bond, 2 square is going to become 4, so you are getting 18.1425. So we got all three numbers using same table, Macaulay, modified and convexity. Alternate, change the yield by 50 basis point. Now it is a semi-annual bond, so things will become on a semi-annual basis. Calculation will be done on semi-annual basis. 12.50 will become, small r will become 6.25, and 11.50 will become 5.75. Calculate new prices using bond TVM keys and calculate the approximate convexity, and this is always giving you a annualized number. Both approximate modified duration and approximate convexity are going to give you annualized numbers. Annualized numbers. Let's move to further. Z bond, very easy. The Macaulay duration of Z bond is always equals to tenure, because only single cash flow is coming, so weight of that cash flow is 1, and it is coming at the end, so your tenure is going to be multiplied with 1, so your Macaulay duration will ultimately become 5-year bond will become 5 Macaulay, will have a Macaulay duration of 5. Modified duration, you have to divide it by 1 plus r. So modified duration is 4.4643. Convexity, you have to multiply weight into T with T plus 1. So it is your 30 is your convexity, not 30 convexity, you have to divide it by 1 plus r square. So 23.9148. So with this illustration, annual, semi-annual and zero coupon bond all are covered, and calculation of Macaulay duration, modified and convexity is done using both table format and your approx format. Of course, you can use closed form equation for Macaulay also. Next, illustration 2. Now we are going to summarize all 6 calculation. Table format Macaulay, closed form equation. Table format modified, closed form equation, approximate equation. Table format convexity and your approximate convexity, and then we will use it for calculating the new bond price, new price of bond if there is a change in the yield. Let's calculate. So now there is a new bond, 100 rupees face value, 10 coupon, yield is 12%. Now I am working with annual, you have to do it with semi-annual. I will share answer in the next part. So settlement date 25 and 28, so it's a 3-year bond. It's 5th September. It's 5th September we are working now. Now next, let's calculate the data. So 3 period. That's why I have keep 3 period, because otherwise the table will become too long. So, but in case of semi-annual, the table will become with 6 rows. There will be 6 periods, and we are working on only coupon dates, because in StudyMat there are only coupon date illustrations. Otherwise, the thing is that this column will become decimal. That's it. Otherwise, there is no change in the calculation. Everything will remain same. So time to receipt in that case will become 0.63 or 0.83 we have done in the modified duration part. Cash flows 10, 10, 10, 10, 10 and 110. Discounted by 12%. We got weight multiplied by time, and time plus 1. We got annualized Macaulay duration. Modified will become modified duration will be Macaulay divided by 1 plus r. In case of semi-annual, it will be 1.06. Convexity, it will be summation last column divided by 1 plus r square. In case of semi-annual, it will be 1 plus 1.06 square, and 4 also, 2 square also in the denominator. Next, what I have done is I have calculated bond price if there is an actual increase in yield of 1%. It means from 12 it became 13. From 12 it became 13%. So using the bond price formula, 13%. Let's put the values: 10 PMT, 100 FB, 3 years, 13 discounting rate. We got the present value 92.9165. Is the actual bond price equation is giving this value, not modified, not convexity, the actual time value of money. Now, next calculation using Macaulay duration calculation using closed form equation. Closed form equation. This is not giving annualized number. This is not giving annualized number. Whereas approximate duration, approximate modified duration, and approximate convexity are always giving you annualized number. Macaulay duration, we have put data in the formula and then we got the same value. This we have already covered, so I'm skipping this. Modified duration, what I have done is I have changed the yield. I have increased and decreased yield from 12 by 50 basis point. I have changed it to 12.5 and 11.5. New prices I have calculated. Same will be used in both the formula. Approx modified and approx convexity. I have done the calculation and 2.4365. We got 2.43625. A bit difference because that is an approximate formula. Convexity, when I put values, we got 8.4457. Let's see what it is giving. 8.4179. So somewhat nearer, but at least giving, we need not to do the complete table working. Directly we can calculate using two prices only. Let's do the working of calculation of bond new price at 13% using only modified duration and using modified duration along with convexity. We have already arrived at the actual price and the actual price is 92.9165. 92.9165. Let's see if the values are nearer to this. 92. What was the value? 92.9165. 9165. And this is 92.9165. Much closer. In case of modified duration, first we will calculate percentage change in PV is equals to annualized modified duration multiplied by change in yield per annum. So it is modified duration value along with negative sign multiplied by 1%. We got percentage change in PV. Put it on the old PV, that is the existing bond price, into 1 minus it's the decrease. So we got the new price, somewhat nearer to exact value. In case of convexity along with modified duration, the first term is same. In second term, we have to add one more term, that is half of annualized convexity multiplied by change in yield per annum whole square. Put values, square, convexity and half. Now this decrease is less than this decrease. The modified duration decrease, that is negative 2.43625, and convexity decrease along with convexity is giving 2.39, lesser decrease. So price will move higher, and we know that curve is always above your tangent line. So it is giving us the new price. So hopefully everyone understood the concept. Do practice with this question, annual bond, annual periodicity as well as semi-annual periodicity. Annual periodicity answer I am sharing, and now please do it same calculation, same bond for semi-annual periodicity. So these are the calculations. I hope everyone understood it. Thank you so much. Next part we will cover more related convexity and bond portfolio. Thank you so much.